Hi, my name is Matthew Hahn, and today I'll be discussing Boolean algebra. So, growing up, you've all been through school system learning addition, squaring, percentages, all the other basic mathematics. The one thing you probably didn't learn is Boolean logic and Boolean algebra. This is a logic gate, and these three, the A, B, and C over here, are the left side of the equation basically. They go through these different operations that I'll discuss later and eventually get the output of Z. First thing we need to learn about is binary number system. So what we use in America is the decimal system, which has 10 digits, 0 through 9. Binary has 2 digits, 0 and 1. So when writing numbers in decimal, you have the ones place and tens place and hundreds place. But in binary, because you only have two numbers, you have the ones place, the twos place, the fours place, and eights place, and so on. So 0 is just 0, 1 is 1, that's the same. And then 2 becomes 1, 0, 3 is 1, 1, and so on. Boolean logic also has two values. Those are true and false. And when using binary to represent Boolean values, you use 1 as true and 0 to be false. The three basic operations in Boolean algebra are conjunction or and, disjunction, also called or, and not, which is the negation. These three can be combined to make any operation that you need in Boolean algebra. So over here, I have this is called a truth table, and it's basically an input and output. So you have two values that you're inputting, and then you're getting output based on depending on what you input. And so for the and, it's the same as it is in English. Basically, for the output to be 1 or true, you need both inputs to be true. Or has the input and output right here, and for the output to be true, you only need one of the inputs to be true, or 1. So you see that here. 0 or 0 is still 0, and then not, or the negation, 0 negated is 1, and 1 negated is 0. There are many different symbols to represent each of them. And is the caret, dot, or the multiplication symbol, an ampersand, or is the upside down caret, plus sign, or double vertical bar, and the negation is the bar, tilde, or an exclamation mark. So then a little more explanation on truth tables. They can be used to show when you have multiple variables, show any different expression you want in the other columns. So here, for two Boolean values A and B, there could be false, 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 true, true, false, or true, true. So there are 4 different options. And then the 3 columns on the right will show you what that expression would be, whether it be true or false. And then you can make these truth tables have any number of columns that you want, representing different values. There are many laws in Boolean algebra, and many of them are the same. The 3 most important, or many of them are the same as in regular algebra. And these 3 are probably the most important, and they're the same as they are in regular algebra. So remember, a plus sign can be an or, and then no symbol or multiplication means an and. So commutative property means the order of the variables doesn't matter. Associative property means when you have 3 of them, the placement of the parentheses doesn't matter. And they're also both distributive. So or is distributive over the and operation, and the and operation is distributive over or. Again, the same as regular algebra. There are many visual representations for Boolean algebra. One being the Venn diagram that I'm sure you've all seen before. So over here, the leftmost one is an and. So everything within the x circle would be considered true if x is true, and everything within the y circle would be considered true if y is true. So then x and y would be the intersection between them, which is the red section. And then The middle one is or, so anything that is within x or y is considered true there. And then this is the negation of x, so everything outside of the circle is considered true. And then when you want to make expressions a little more sophisticated, then we would move over to the logic gates that I showed you at the beginning. This is an AND gate, this is an OR gate, and a NOT gate. As you can see, the AND and the OR gate both have 2 inputs and 1 output. So it would be like earlier, x and y would give you the z value depending on the x and y. And you can chain many of them together to create a logic gate to solve complex problems. Some of those problems being in computer programming, creating algorithms, and low-level programming within the machine use binary and Boolean algebra a lot. Also, critical thinking. Having a basic understanding of Boolean algebra would help with your everyday critical thinking and problem solving, just because it is the basics of logic. And it also applies a lot to creating and understanding electric circuits. So in an electric circuit where you have switches, the switch being on could be considered true, and the switch being off could be considered false. And that would help you, having an understanding of Boolean algebra would help you understand that and help build complex electric circuits.